Good evening, everyone, and welcome back to our Calculus CRAM session number 9. Tonight, we're going to be looking at multi-topic sample FRQs. My name is Jamil Siddiqui, and I'll be your host for this evening. It's great to have so many of you back. We're getting close. We're getting close to the end. The exam is just a couple days away on Tuesday. We're going to be streaming tonight, of course, and then we've got one more big stream planned for you on Monday night, okay, the night before the exam. So let's get started tonight without any further ado. Here we go. As you guys all know, this is our weekly calendar. Please tune in for any of the AP exams you have left. We've got 2 weeks of AP tests coming our way. Calculus is pretty much the leadoff one. It's on day 2 next week. Our next and final CRAM session, which is strange to say. It seems like we just started these, but our final CRAM session will be Monday. We've got a 5-hour marathon planned from 4 p.m. to 9 p.m. I will be live with you guys from 7 p.m. to 9 p.m. Eastern time. I'd love it if you guys would send me questions to my email, send me questions in the chat. Let me know what it is you want help with that night, okay? I'll build it to help you. I'll be taking questions live on the air as we're going, so if you have a question, you can just ask it right then and we'll talk about it. This night is designed to help you guys out with whatever you need for those last-minute preparations as you get ready for that exam we've been working for all year on Tuesday. And of course, the Fiveable Olympics have begun. They're going on now. Hopefully you guys are on a team and trying to earn some points so that you can win some of the prizes that the great Fiveable team has put together for you. And as always, follow us at Think Fiveable and make sure you're on up to date with all of our social media so you know what's going on. Tonight, we're going to talk exam information very, very briefly. It's been in the last 2 streams I've done. If you need more information than I give you tonight, please feel free to go back to one of the replays. I'm just going to hit the highlights tonight. We're going to talk about sample-free responses that myself and several of my colleagues who are consultants for the College Board are predicting this year's exam will look like. Again, no one really knows for sure. We're in unexplored territory, but we are going to be making our best predictions, okay? Nikki has asked the question, what portion of the final CRAM will cover AB and what portion will cover BC, okay? Obviously, if you're in BC Calculus, everything is covered because everything in AB is covered on BC. If you're only taking AB Calculus, okay, I will always say before I start a problem whether or not it's BC strictly, okay? So it's going to be BC only. We haven't broken it down to, you know, 4 to 5 for one, 6 to 7 for another. It's kind of all mixed together. But I will make sure whenever I start a problem, I will make it very clear, hey, this is only going to be on the BC exam. So if you're an AB exam taker, you can kind of tune out for a few minutes and then come back when we finish that problem. So here's the exam info. Your e-ticket. 2 days before your exam, you're going to get it in your email. I've heard rumors that you've already got them. If you visited myapcollegeboard.org and went to your account, they're already there. But you should be getting your e-ticket in your email 2 days before the exam. Make sure you have that to log into the exam. That's going to be vital. And then, of course, the date for our exam is Tuesday, May 12th. Remember, it is 2 p.m. Eastern time. Okay, 2 p.m. Eastern time. So hopefully you'll adjust for your time zone and get there at the right time. The format of the exam. Question number 1 is 25 minutes. Okay, so you'll have 25 minutes to take a question 1. The prediction I'm making, we're going to see probably 8 parts to that question, okay? Could be 7, could be 9, but I'm predicting right around 8 parts. And remember, there are going to be more parts than there is time to answer. Do not be alarmed if you run out of time. That is not going to be a problem, okay? So do your best, work hard, get as much done as you can. If you don't get to the last question or the second to last question, don't let that throw you. Come back strong on the next question and make sure you keep your head in the game because everybody is going to have a hard time finishing these questions on time. When that 25 minutes is over, you'll have 5 minutes to upload your answer. There's been a lot of discussion in the calculus about taking a picture and uploading it. Yesterday, I believe it was yesterday, the College Board came out and said PDF format is available. So if you have a phone that can convert to a PDF instead of a JPEG, that is perfectly okay. Okay, I advise all of you to go to the College Board website simulation and practice uploading these questions just so you know what it's going to be like. You don't want the first time you upload is to be Tuesday during the exam. You want to have it down. You want to understand how it works. So please go in and give the simulation a try. And one last thing about the upload, as long as you have started the upload process before that 5 minutes is over, you're good to go. You do not have to complete the upload process. Okay, you just have to start it. So make sure that you get it started before the 5 minutes is over. It can continue to upload as you go on to question 2. And speaking of question 2, Question 2, you'll have 15 minutes, okay? The predictions there might include, I'm expecting us to see somewhere around 5 parts to question 2, potentially even 6. Again, they're going to write it long. Don't be alarmed if you don't get a chance to finish every question. Just get through as much as you can and concentrate and give your best effort, and you should be all set. Like I said, the majority of students are not going to finish this exam on time. Same deal with the upload. You're going to have 5 minutes at the end of the 15 to upload. As long as you hit upload during those 5 minutes, you do not have to complete the upload. You just have to start it. And then for those of you that have done question 2, make sure you stay online until you get the screen that says they have received your upload, that your upload is complete. You do not want to hit upload and then shut down. You want to make sure that you get the upload is complete screen from the College Board before you stop, okay? And just one more note about exam day. Do not hit your refresh button on your browser. Do not hit your back button on your browser. The College Board has this set up so that the screen will change automatically at the right time. If you hit refresh or if you hit back, you're going to have to go through the process of logging into the exam again, which is going to cost you precious time. So no refresh, no back, just let the exam move on its own. It will change on the appropriate times. Next thing I want to do is I just want to give you a list of some exam tips. We're going to repeat these tips on Monday. We're probably going to add to these tips on Monday as well. But these are just things that I was thinking about right before we started tonight that I want to get out to you guys so it would be fresh in your mind. So exam tips. You do not have to simplify any of your answers, okay? Do not simplify anything. If you have an arithmetic statement, you do not have to go any further than that. If you have a function notation, you do have to complete that. If you have f of 7, you do have to state what f of 7 is as a numerical value. But as long as it's some kind of numerical expression, you're good. I see Nikki over on the side asking about screen buffering. The word I have been given directly from the College Board is do not hit refresh. Okay, just let the exam run through. That is what I've been told over and over and over again. So I'm staying with that, and that's what I'm telling my own students. And for all practical purposes, for the last 2 weeks, you guys are my own students. So I am telling everyone, do not hit the refresh button. Exam tip number 2 for us tonight, remember your units. Units are a vital part of answers on the College Board scoring guides. Typically, if you leave units off, you lose a point. You want to make sure you include the units in the problem. Exam tip number 3, if you're going to be using one of the theorems, and those theorems are the mean value theorem, intermediate value theorem, extreme value theorem, and even L'Hopital's rule, which technically should be listed as a theorem and not a rule, you've got to state the conditions before you use them. So remember, this is when the STEM is going to say something along the lines of your function is continuous, or your function is differentiable, or your function is twice differentiable. And of course, in the case of L'Hopital's rule, you've got to show the indeterminate form. Make sure you show 0 over 0 as 2 separate limits. Always do the limit of the numerator as a separate problem, the limit of the denominator. Show they both go to 0, or show they both go to infinity in case of an infinity over infinity indeterminate form, and then take the derivative of the top and the bottom and bring them back in the same limit. This is a big one, chain rule. There are a lot of problems that we've been seeing online that people have been writing lately in anticipation of this year's exam. We're going to see one tonight where you've got to use the fundamental theorem of the calculus, and you're taking a derivative, and the chain rule is a vital part of that. Make sure you're thinking chain rule. If your inside function is not just an x, it means you've got a chain rule. So we're going to see that tonight, and we're going to stress it, but just always, when in doubt, use the chain rule. When justifying and explaining, do not use any pronouns to refer to any of your functions, okay? Don't say, the function is increasing because it is positive or it is negative. You've got to say the actual noun. You've got to say the derivative, okay? So no pronouns at all. When you're doing a substitution integration, it is very useful to bring the bounds with you and write them in terms of u. It's not a necessity, but for a lot of my students think it's easier. It's a simpler way of doing it. So just remember, when you're doing an integration, bring those bounds over when you do the substitution. We'll see an example of that tonight. This is for your integration. It's particularly your separable differential equations, okay? Remember, separable differential equation, if I were betting, I would all but guarantee we're going to see a separable differential equation on the AB exam. So when you integrate, don't forget that plus C on the independent variable side. You're going to use your condition to find that constant eventually in that problem, but just don't forget the plus C. That is a 2 to 3 point mistake on a separable differential equation question. And again, did I mention the chain rule? This is a big one. Just always use the chain rule. Here's one that's kind of a very specific one, but a lot of times they'll ask you to justify whether you've got a maximum or a minimum. And a lot of us like to use the first derivative test, which basically says if your derivative is positive before and negative after, you're increasing, the function increases and then the function decreases. So that is a maximum. Perfectly valid. But remember, there is a second derivative test for max and mins as well, where you take your critical point, you plug it into the second derivative, and you find the concavity. If you've got a critical point on a concave up shape, you must have a minimum. If you have a critical point on a concave down shape, it must be a maximum. So if your second derivative is negative and your first derivative is 0, that means you've got a maximum. If your second derivative is positive and your first derivative is 0, that means you have a minimum. My students use the first derivative test over and over and over again to the point where sometimes they even forget the second derivative test is something you can use. Keep it in mind. You may have a table where they give you a second derivative value, and that's the only way you'll know. So just remember the second derivative test. And then, can't stress this enough, make sure you submit during that 5-minute window. If you have a technical difficulty, if your computer breaks down, if there's some kind of something out of your control, you can take a retest. You can apply for a retest if something goes wrong. If you miss the submission during the 5-minute window, you get a 0 on that question and there's nothing that can be done. Okay, you can't call the College Board after and say, I had my work done, I just forgot to hit submit. This is vital. Make sure you get that submitted during the 5-minute window. Okay, some of you are going to be working on a problem, you're like, oh, I can just take 2 more minutes, I know I can finish this problem. Just remember, if you finish a problem, you're talking about getting 2 more points. If you don't submit it, you're losing all of those points. So just make sure you get it submitted. I can't stress that enough. And then one of my favorite basketball coaches from the 60s and the 70s, John Wooden, had this quote. He said, be quick, but don't hurry. That's what you want to do on this exam. You want to move through it quickly, and that means you're focused, and that means you're deliberate, and that means you're working steadily, but you don't want to hurry. You don't want to rush. When you rush, you make careless mistakes. Avoiding careless mistakes on this exam is huge. Normally, you've got 6 free response questions and 45 multiple choice questions. If you make 1 careless mistake or 2 careless mistakes, it gets absorbed because there's so many points, there's so many questions. We got 2 questions this year. Every careless mistake is really going to hurt you. You have to fight for every single point you get. So don't worry about trying to finish. Be deliberate. Be quick. Be consistent, but don't rush. If you hurry, that's where the careless mistakes are going to come in. We're going to look at a couple of questions. Here's the first one. I'm just going to read the chat just for a second and see if I've missed any of the questions over here before we begin. Can I explain the intermediate value theorem and the extreme value theorem? Ask me that at the end of our session tonight. I'll stay on another 5 or 10 minutes, and if we don't have time, I'll definitely get back to that, okay? But I'd like to go through our questions first, and then I'll stick around at the end if you want to talk about that. So just remind me at the end when I ask if there are any questions, we'll come back to it. Aside from that, I think we are good. Okay, so I'm going to switch over to my tablet, and then we're going to start working this question right here. So give me just a moment. Okay, so a lot of us at the College Board who are consultants have been trying to figure out what the exam questions are going to be like. If you've been following along on the YouTube channel in the morning with either Brian Passwater and Tony Record for the BC or Verge Cornelius and Mark Crowley for the AB, you've seen very similar questions, okay? And the questions that we're talking about here have to be fair for all students, and that means we can't give students who have more technology than others an unfair advantage. That means the questions where you're giving a graph like this are really in play because this levels the playing field. If I have a computer, I can't put this into my computer and ask it to do calculus for me, okay? So we're really predicting seeing a lot of questions like this, and that's why we're practicing on this tonight. And you can bet we're going to do some of these on Monday night as well, just to review. But we're going to go through this problem here. This isn't exactly mirroring an AP question because I haven't worried about trying to make 8 parts for question 1 or 5 parts for question 2. But I just think these are the types of things that we're going to be seeing, okay? So I can tell some of you guys are already reading it. I'm just going to be quiet for 30 seconds just so you guys can read it and start thinking about it. And then we're going to go. And I'm going to take a look at some of the comments. All right, so one of the things that we have seen on the AP exam a lot over the last 10 years is an integral defined expression. Okay, so I'm highlighting that integral defined expression right there. But as somebody noticed over in the chat, there's a slight difference to this one. And I'm going to make sure we can actually see it. I'm going to blow up on this one. Most of the time, they're just giving us an X here. But today, we've got a 2X. And that is going to cause us some problems if we're not really careful about this. Okay, so I just wanted to make sure everyone could read that and see that really well. A 2X is going to be a slightly different approach on this problem. So how come? Why does that change things? So let's take a look and let's work on this problem together. You're going to notice we're asked for the function g, the derivative g, and the second derivative of g. It might be a good idea for you just to get all three of those functions ready at the very beginning. Okay, you might just want to start by saying, let's figure out what those three functions are going to be. So if I do that, I know that g of x is already defined for me as the integral from 2 to 2x of f of t dt. So I'm comfortable with that. But now here comes the tricky one. What's g prime of x going to be? Okay. Now a lot of people think, hey, if you've got a derivative of an integral, they're just going to cancel. All right. But this is where you've got to be careful because of the 2x. You've got to use the fundamental theorem of calculus. My advice to you is to do this. Don't try to take the derivative of this integral expression. Use the fundamental theorem of calculus to help you. The integral of little f is defined as big F. So we're going to have big F of the top bound minus big F of the bottom bound. And now that top bound is 2x, and that bottom bound is 2. So now you've got a choice. I want to take the derivative of g of x. So I'm going to take the derivative of g of x, and I'm going to get g prime. That's easy. But now, do I want to take the derivative of this integral expression, or do I want to take the derivative of the fundamental theorem expression? And the answer is always the fundamental theorem. You want to take the derivative of that piece. So I'm going to come over here, and I'm going to take the derivative of big F of 2x. And this is where the chain rule comes into play. You've got an inside function here. This has to be a chain rule. The derivative of big F is little f. You're going to copy the same inside function. That's going to get you 2x. And now you're going to take the derivative of that inside, and that's going to put a 2 on the outside, okay? So I see Rashika over there. You've got it. You nailed it. That's exactly what's going on in this problem. But don't get careless on the second one, because I've seen a lot of my students screw up big F of 2's derivative. They get complacent. They just think, oh, the derivative of big F is little f. So this is little f of 2. Chain rule, people. Chain rule. You got to do the chain rule because it's not an x. It's a 2. So if I do the chain rule on this, the derivative of big F is little f. But now I copy the inside of 2, and here's where the chain rule saves us. The derivative of 2 is 0. So that wipes out that term. The common sense way of saying this is when I look at this term right here, there's no variable. If there's no variable, it's a constant. And if I take the derivative of a constant, it's 0. So this is why the chain rule and the fundamental theorem are so important. But now I know that g prime of x is equal to 2f of 2x. Okay? And now I'm in derivative mode, so I might as well go and I might as well find that g double prime of x. So now I'm going to take the derivative of what I just found, and this is going to be the chain rule again. Because now I'm taking the derivative, and just make sure you guys are looking where I'm looking, I'm taking the derivative of this expression. So the derivative of this is going to be f prime gets the derivative of the f, copy the 2x gets me the inside of 2x, and now I take the derivative of that inside, which is 2, but there's already a 2 there, so it becomes 2 times 2 in the front, which is 4. So I've got my three functions. Now I can go and I can answer the question, what is g of negative 2, g prime of negative 2, and g double prime of negative 2? So I'm just going to give myself a little more space down here, and we're going to nail these questions. So doing g of negative 2 literally means plugging into this integral expression. It's 2, and now be careful. We're really used to this just being an x. You might be tempted just to write negative 2 without thinking, but remember, you're plugging in to 2x. So you've got to multiply that negative 2 times 2, and that's going to make it negative 4 up there. So our bounds on this are from 2 to negative 4, and now we're doing f of t dt. And this is where the geometry comes in this problem. We're going to see a graph like this. I can almost guarantee, in my mind, they have to give us one like this. It's the fair question. And you see all the geometric shapes. Well, in our problem here, we're going from 2 to negative 4. So that means we're starting here at 2, and we're working our way back to negative 4. Now, I like to kind of shade both of my shapes individually with different colors. And Those are the regions I am talking about, okay? And again, I see the question, how did I get the -4? Remember, the top bound here is 2x, okay? That top bound right there is 2x. So we're plugging in -2 into that 2x, and that's getting us -4, okay? So now from here, all I've got to do is use my integration to get this answer. If you were with me earlier last week when we did the fundamental theorem, I talked about how I like to find the sign by looking at my factors here. I always do it this way. There are other ways of doing it. If you do it in a different way, feel free, as long as it's working. I'm just going to be consistent the way I taught it on the stream last week, because the top bound is less than the bottom bound. We're moving to the left, and whenever we're moving to the left, the dt is going to be negative. Okay, so now when we look at the orange region, that's below the axis, which means my f of t is negative. So that means for the orange region, that answer is going to be a positive because both factors are negative. So this region right here is going to get assigned a positive value. So now when I go and I continue, and now I'm talking about the blue region, I'm still moving to the left with dt, so that's negative. But now my f of t is above the axis, so that's positive, which means my overall answer is going to be negative. So I am going to get a positive orange region and a negative blue region in this case, because of the way the signs of the integral work. And again, it's because I'm moving to the left. Now, some of you guys are going to ask me, can I just reverse the bounds and put a negative in front of the integral? That is completely acceptable. It is exactly the same thing mathematically. It's just a different way to think about it. So if you're used to reversing the bounds and going and putting the 2 on top and the -4 on the bottom, and then using a negative in front of it, perfectly okay. Okay, but if you followed along with my stream from earlier last week, we talked about using the factors and finding the signs. So I'm just being consistent with that. So now remember, the positive one is the orange region. That is a triangle. So I'm doing 1/2 base times height. The base of that triangle is going from -2 until 2. So we're talking about a base of 4. The height of that triangle is going from 0 to 2. So we're talking about a height of 2. And that is the orange region. Now we're going to go to the blue region, and the height of that one is 3. So again, this is a triangle, so it's 1/2 base times height. So the height is 3, and the base down below is 2. You're done. Circle this answer and move on. We are not simplifying any algebra, any arithmetic expressions on this exam. It's just going to take you time, and you got full credit right now. If you make a careless error on this, you're giving up points. So walk away and say you are done. Okay? Well, you're done. Again, the reason the dt is negative in this problem, anytime the top bound is less than the bottom bound, your dt is negative. That's how you know. It's the same as thinking about this as moving to the left. Okay, so your teacher may have said that to you. If we're integrating to the left, we're going to have a negative in that factor. Okay. From here, we are going to do g prime of -2. But according to the derivative we found earlier, g prime is equal to 2f of, and again, there's a 2x in there, so I've got to multiply my -2 times 2 to get -4. Okay, so at this point in time, I'm just going to figure out what f of -4 is, and I'm going to be getting my answer. So f of -4, well, this is the graph of f of x, so all I got to do is plug in -4 into this graph. So when I go f of -4, that is basically like me going over to this input right here and finding this output right there. That's f of -4. So f of -4 is going to give us the value of 3. Again, if you want, you can leave your answer 2 times 3 and walk away. This one's pretty simple. I'm going to go 6. I see Mint's asking me a question. If I need the numerical answer later, can you simplify it then? Of course you can. If for some reason knowing that expression as a single number is helpful in a later part of that problem, you can always do it later, okay? But if I leave the non-simplified version right now, I am guaranteed full credit on this part A, let's say. If I need it in part B, I'll figure it out in part B, okay? I don't want to lose any points in this part A, all right? So is everybody good with our answer for g prime of -2? If you are, give me a thumbs up. If things are going well, let me know how we're doing tonight, okay? The next part is g double prime. Yeehaw, thank you, I appreciate that. G double prime. And again, we're going -2 on this one. So if we put in a -2 into this one, this is our g double prime, we're going to have 4f prime. And again, we're multiplying by 2, so -2 times 2 gets us that -4. So on this one, just be careful. All of a sudden, it's not f, it's f prime. Just remember, every time you're looking for f prime, that means the slope of f. So this expression right here means the slope of f of x at x equals -4. That's what we're looking for. So when I go up to my graph and I am trying to find the slope of this graph at -4, I'm talking about the slope of that line segment right there, that green line segment I just highlighted. So this is now just, algebra. I just got to use a little rise over run to get this answer. So again, this answer is going to be equal to 4 times the slope of that line. That line has a rise of going down 3 and a run of 2. So our slope there is going to be -3/2. Circle it and be done. Don't get fancy with these answers, okay? Don't simplify them. So here are the answers for this first question. I hope everybody's feeling good about this. We're actually going to build off this question a little bit in question 2. But if you have any questions right now on question 1, put them over on the chat. Be happy to discuss them. So in question 2, you can see it's kind of a similar expression. This time we're asked for g of 6 and g double prime of -1. Let's take a look at g of 6. G of 6 is the integral from 2 to 2 times 6, which is 12, of f of t dt. The way we're going to get this is we're going to look at our graph and we're going to use our geometry again. We're starting at 2 and we're going over to 6. Now, I'm actually going to switch colors there because I feel like I've got a new shape that starts there. Okay, so there's my next shape. And then I'm going to keep going all the way until 12. So I'll highlight that with another color and go until 12. Okay, so really these are the shapes I'm talking about. I got a question. Are we really fine with no simplification on the rubrics? I always see that they're simplified. Although they're equivalent, I don't lose any points. Jillian, believe me, I am not telling you a lie on this one. No arithmetic simplifications is necessary. You do not have to simplify anything. It is, you can go as far as that. Even this one, okay? Obviously, the ones I did before are very, very basic arithmetic. You could leave this for a final answer. If your final answer was the sine of 3 pi over 2 minus the tangent of pi over 4, all divided by the square root of 4 squared minus 6 times 2 plus 1, perfectly acceptable, okay? All of these are numerical values. You do not have to simplify it. The reason they're written as simplified answers on the College Board rubrics is just because they work them to completion. And yes, you do not have to solve for sine. Okay, sine 3 pi over 4 is 3 pi over 2 is a constant. You can leave that exactly the way it is. Okay, just like you can leave the square root of 5, you can leave the sine of 3 pi over 2. Both of these are functions with inputs that you just didn't simplify. Perfectly acceptable. Okay, perfectly acceptable. So the only simplifications that you have to make, okay, the only ones you have to make, if I do the integral from 0 to 1 of x squared dx, that's a constant. But this is a calculus simplification. So you do need to work that out to some arithmetic answer. Okay, you don't have to simplify the arithmetic, but you can't leave it with calculus notation. You also cannot leave something like f of 2. Okay, you can't leave that because they're telling you you need to be able to read your graph. So I know f of 2 is found from the graph, but they're testing to see if you can read a graph. So you would have to read the graph, and in this case, get f of 2 is -2. Okay, so you can't leave a calculus expression unsimplified unless it says in the directions, and you can't leave the function expression unsimplified. Anything arithmetic, you can leave it. The same is true for Riemann and trapezoidal sums. Do not touch those. That would be a complete waste of time. Riemann and trapezoidal sums, you do not have to simplify at all. Okay, so we're going to see some more simplifications. Let's go through some of these other problems. You're going to see me leave some simplifications. Write down your notes, ask as we go along, and at the end we can totally go revisit this question to make sure you guys are comfortable. Okay, I'm expecting today we're going to go a little longer than an hour just because we're close to the exam, and I really want to get you guys as much help as I can tonight. So this question here that I'm working on with the integral, here's the deal. Okay, The only reason I'm even bringing this up, and I want to warn you ahead of time, in the last 30 years of AP exams, I have only seen this happen twice. So I don't think we're going to see it this year, but I just want you to be prepared. When I go to do this problem, and I'm going to go and do my sign analysis again, well, DT is moving to the right the entire time, so we're positive. So DT is always positive. So basically, if you're above the axis, you're going to get a positive result. If you're below the axis, you're going to get a negative result. So the blue is going to be a positive result because f of t would be positive and dt would be positive. The orange is going to be a negative result because f of t would be negative and dt would be positive. And both the greens are going to be negative for the same reason. The green is below, but dt is positive. So when I look at this, I am going to get a negative answer for the green. I'm going to get a negative answer for the orange. And I'm going to get a positive answer for the blue. This, we're going to see this. There's no question in my mind we're going to see something like this. But where this question gets a little tricky is when we start finding the actual areas. And I'll explain that in a minute. So now I'm looking at the green region, okay? And when you're looking at this green region, the green is not a shape I know. It's a combination of two shapes I know. So if you were finding that green region, you've got to think rectangle minus semicircle. So the green is going to be base times height minus, and I need to give myself just a little more space here, minus pi r squared over 2, because it's the rectangle area minus the semicircle area. Okay, so when I find the base of that rectangle, it goes from 2 to 6, which is 4. When I find the height of that rectangle, it goes from 2 to negative 2, which is 2. And when I find the radius of that circle, the radius of that circle is 2. So that's where I'm leaving that answer right there. All right. So now, when I go to do the orange triangle, I know that's 1/2 base times height. And the height of this is very simple. The height is right here. That height is 2. This is the part I just want to make you aware of. I don't want to scare you. I don't want to stress you out. It is rarely asked, but once in a while, like twice in the last 30 years, you needed to find a specific value. Now, if you zoom in on this, you can see that the base of this triangle doesn't stop at 7. It goes past 7, okay? Again, they don't ask it often. I've only seen it twice in 30 years. But if it happens to show up, I just don't want you guys freaking out about it. So the way you're going to figure that out is you're actually going to find the equation of this line right here. And then you're going to find the x-intercept for it. You're just going to find the equation of that line. And the equation of that line is going to be found by y minus blank equals the slope times x minus a blank. You're going to find a point on that line. Here's a nice point right here. This is 10, 4. Okay, I'm going to put in 10, I'm going to put in 4, and now I'm going to find the slope of this line. The slope of this line, I'm going to find 2 points that work. There's 1 and here's 1. So I go over 2 and up 3, so I'm going to get 3/2. Now to find the x-intercept, I'm going to make y equal to 0. And I'm going to solve this for x, okay? When I make y equals to 0 and I solve this for x, I am then going to find the value that I need, okay? So when I do that, what I'm going to come up with is actually 7 1/3. Okay, that is the value that we're looking for. So 22/3 is the answer. Now, let's just talk about this for a second. Someone's asking me, can I estimate? The answer to that is no. They're asking you for an exact answer. You need to have an exact answer. Someone else might say, can't I just use the slope? I know the rise over the run. Can't I use that? If you're good with proportions, of course you can. Okay, if you know the rise over run is 3/2, you can figure this out. Okay, but I'm telling you the safest way to do this is to find the equation on that line. Now, again, I don't mean to worry you and freak you out 5 days before or 4 days before the exam. They hardly ever ask this. It is almost always a whole number value that you read from the graph. So please understand that. I am just sharing this with you on the off chance they do it. I don't want you guys being in the middle of the exam and never having seen it before, okay? So the chances of this happening, very slim, but if it does happen, you know how to do it now, okay? So now, from here, I can finish this off because let me just blow this up again. This is going to be 1 1/3 right here, so that's a length of 4/3, okay, because I'm going 1 1/3. While I'm at it, I'm actually going to do my trapezoid right here as well. This is a length of 1, 2, 3, 4. That's 4 2/3. Okay, that's 4 plus 2/3 right there. Which again, you could write as a single fraction if you want. But remember, we don't have to simplify. So I'm just going to leave it as 4 plus 2/3. Once you're here, geometry takes over. Okay, and we can finish this off. So we're filling in the base of that triangle. That was 4/3 right there. And now we've just got to do the trapezoid. So the trapezoid is, I'm actually going to write it up here so I have more space. It's the average of my bases times my height, and that's going to go in here. So the first base is that 4 plus 2/3. That's my bottom base. And notice I'm not simplifying at all. And the top base is this guy right here. It goes from 10 to 12, so that's 2. And then my height of my trapezoid connects the two parallel lines, and that is going to be 4. I put that in that blank. I am done. That is it. I don't have to do anything else in this expression. That is my answer, okay? So again, one last time, I'm not going to harp on it. I don't think you're going to have to find the x-intercept. I truly don't. I just know it's been asked in the past, and I want you guys to be completely prepared. So please don't worry too much about this. But if it does happen on the exam, you have my email. Be sure to email me and thank me, okay? So that is the G of 6. Next question, G double prime of 1. If you remember from our last problem, we said that G double prime was equal to 4f prime 2x, okay? 4f prime of 2x. So when I come down here, G double prime is equal to 4f prime of 2x, okay? Excuse me. All right, so once we've got that, we're being asked to find G double prime of 1. I'm sorry, negative 1. That's like saying 4f prime of negative 2. So I am now finding the slope of the graph of f at negative 2. So the slope of the graph of f at negative 2, we are talking about finding the slope of the graph right there. Now, what are you guys going to tell me about that? Give me some feedback. We got it. Yeah, there you go. Does not exist. We've got a sharp point here. You may call this a sharp point. You may call this a corner. You may call this a cusp. All of these are saying the exact same thing. Your slope coming from the left side is this orange line, and your slope coming from the right side is this green line, and they do not agree at negative 2. Since the slope from the left does not equal the slope from the right, all you have to do here is write does not exist. You can write undefined. You write either of those answers, and you are good. DNE, UND, both perfectly acceptable for abbreviations on the AP exam. Okay, so DNE and UND does not exist, undefined. Now, this question does not ask you to explain. It does not ask you to justify. So I would be done in this case. However, it is very common for them to write justify with this answer. So if I were writing justify in this answer, I would write the limit as x approaches negative 2 from the left of f prime of actually, I got to be careful how I write this one. I want to be really careful how I write this one. Let me back up. I write the limit as x approaches negative 1 of 4f prime of 2x, because that's what we were using, okay? So this is what we're using. Does not equal the limit as x approaches negative 1 from the right, and I need the left on this one, of 4 times f prime of 2x. And then I would go back and I would compute these slopes. So the slope here is a rise of 3 and a run of 2. So that was negative 3/2. And the slope of this other one was a rise of 2, I'm sorry, rise of 1 and a run of 2. So that's negative 1/2. Okay. This would be perfectly acceptable. Because I wrote this statement right here, everybody look where I'm writing right now. Because I wrote this, I do not have to write G double prime of x here and G double prime of x here. I made that link so I can go straight to my f. Okay, so I hope that makes sense. I'm just reading the questions over here. If we say DNE, do we have to justify it if it does not explicitly say to do so? You do not. You only have to justify if it specifically asks you. So the way I had this question written, we were done without the justification. All right. So I hope that's clear for everybody. I hope you guys are feeling good about these two questions. If not, always put something over in the chat. We'll talk about it some more. But I would like to move on to the next one. So in this next one, okay, what we've got going on in this one, we're given a function. We're asked to find a derivative for. I would like to give you guys a moment to work this out, okay? So I'm just going to give you guys a moment. I'm going to go back. I'm going to read all the questions in the chat, make sure we're good. Let's talk in another 30 to 60 seconds. So go ahead and try to find this derivative, k prime at -4. I have written my derivative on the screen. You guys can double check your work with mine if you'd like. This was a product rule, and there were a couple of chain rules involved in this problem. So you had to use the product rule overall, but then you need to use the chain rule on some parts of it. I want to remind you of one thing. We're going to be going later than an hour tonight. I'm happy to stick around and get through all the problems. So I'm not worried about rushing. If you guys have the time, I've got the time. We're going to stick around and make sure we get through these problems and answer all of your questions. Second thing I want to look at is one of the questions that just popped up. If we use L'Hopital's mean value theorem, etc., must we justify? If you are using L'Hopital's rule or the mean value theorem or any of the theorems in the free response section, you must state the conditions are met. You must, okay? So that is a given. If you see L'Hopital's rule, mean value theorem, intermediate value theorem, extreme value theorem, yes, you've got to state the conditions on that one, okay? So on this problem now, if everybody's good with my derivative, give me a thumbs up or some kind of a feedback if you're good with the derivative. And if you are, I'm not going to go over it. If you have a question, put it over there, okay? Because at this point in time, all we're asked to do now is plug in -4 into this expression, and then we just got to make sure we can read a graph correctly. So I'm plugging in -4, and when I plug in -4, I'm getting 2f prime. Now, when I plug -4 into that 2x plus 9 mumbo jumbo, I end up with a 1. I now do the ln of f of -4. I'm going to do f of, and that's going to become 1 again for the 2x plus 9. And that's going to be times f of -4 on the bottom. And that f prime of -4 is just going to jump to the top. Okay? Now, these are the simplifications you have to make. This is notational. This is not arithmetic. You need to fill in each of these values. So everywhere you see a derivative, we're talking about a slope. So I'm looking at 2f prime of 1 to start with. F prime of 1 is the slope of that green line right there. Okay. So when I'm talking about the slope of that green line right there, the slope of that green line, that slope is equal to -1/2. So here we go. This is equal to 2 times -1/2 goes in for f prime of 1. Now I've got the natural log of f of -4. I'm looking at my graph. I'm finding where that f of -4 is. That is this point right here. So f of -4 has a y value of 3. That becomes the natural log of 3. From there, I continue onward. Okay, now it's plus f of 1. This one's a little tricky. Okay, f of 1 is not a whole number. But remember, we know the slope on this one. So you could write the equation of this line like we did before and plug in 1. That's one way you can do it. But this one's even a little easier to use with slope because we know we're going over 2 and down 1. So that means if we go over 1, we've only gone down 1/2. So this is halfway between -1 and -2. This value right here is going to be -3/2. Okay, so again, I could use that equation in the line like I did in the last example, but again, with a slope of -1/2, we should be able to use our ratios to figure out that that's just halfway between -1 and -2. The next expression I'm looking for is f prime of -4. F prime of -4 is another slope. So f prime of -4, that is the slope of this line right here. We found that a little earlier. We said that that was down 3, I believe, and over 2. So that's going to be down 3 over 2. That's going to be -3/2 for that guy. And that was my f prime value. And now I've got a denominator of f of -4. So f of -4 is the y value at -4, which we already found. We found that to be 3. Okay. So for all of our talk about simplification, you ready? Here we go. I'm done. You don't have to touch this mess. This is arithmetic. Even something like the natural log of 3, you might be like, well, don't have to work with that function. No, you don't. You are completely done here, okay? You can leave this answer, you can circle it, you can move on. You can leave the complex fraction. That's not a big deal. You can leave the natural log. Not a big deal. You can forget that 2 times 1/2 is 1. Not a big deal. All arithmetic simplifications can be left. So I'm stressing that because we had a lot of discussion about it earlier. I'm banging the drum to make sure you guys are clear on that. I don't want you wasting time during this exam making these simplifications. So I hope everybody is good with this question. Any questions at all on this guy? Again, the whole idea is being able to read this graph correctly. Next one. Let's do an integral, okay? Now, this is a notational integral for part of it, but there are terms in this integral, okay? You've got this f prime stuff going on, but you also have a 5x going on right there, okay? My advice to you is to just right from the very beginning, make this 2 separate problems. Take this from -3 to 1 of f double prime of 2 minus 2x dx, and then make it minus the integral of 5x dx from -3 to 1, okay? And just do these completely separately, okay? Completely separately. Now, the one over here on the right, the 5x dx, that's a pretty straightforward integral. That's going to be equal to, and again, you want to be careful with the equal signs on this, okay? I am literally like drawing a divide here. I've got 2 completely separate problems, okay? They're not part of the same expression anymore. So the one over here on the left, what I'm going to get now is this is going to equal -5x squared over 2, and I'm evaluating this from -3 to x equals 1. X equals -3 to x equals 1. So the way I like to write that is I like to write -5/2 on the outside, and I like to do my fundamental theorem of calculus on the inside, where I'm just going to get something squared minus something squared, and I'm plugging in 1 in the top bound, I'm plugging in -3 on the bottom bound, and I am done. I am good to go. I do not have to touch this again, okay? So now I've got to go over on this other part, and I've got to do my integral of f double prime. So for this one, for all you AB students out there, you got an inside function, okay? You got an inside function. So now, anytime you've got an inside function in an integral, you AB students, you're thinking use substitution. Matter of fact, that's true for you BC students too. I shouldn't just say AB. The only reason I'm stressing AB, BC guys, you've got to be familiar with your other techniques of integration that the AB kids don't need to worry about. You've got integration by parts, you've got partial fractions. Integration by parts could have an inside function as well, so you got to be a little careful on that. But the general rule is if you've got an inside function, you're going to do a use substitution, or for some of you guys, I know you like to call it the reverse chain rule. It's the same idea. So I'm going to go and I'm going to set this up by doing a u equals 2 minus 2x. I'm going to do a du is equal to -2 dx. And I'm going to go one step further and say that dx is equal to -1/2 du. All right. So now I've got this set up, and that's going to help me do my substitution. I am now going to start writing this integral in terms of u. So my f double prime is a function. It's going to come right over. My 2 minus 2x is going to go into that box as 2 minus 2x. It's going to leave that box as u. Okay. I am now going to go and take my dx into this box, and it enters the box as dx, but we see right here it's going to leave as -1/2 du. So that -1/2 can go in the front of the integral, and that du can go at the end of the integral. Now, I believe in bringing the bounds over. This is one of the things I mentioned in tips. You may have noticed I like to write x equals on my bounds. This is precisely why. Those are x values. I want them now to be u values. So my question becomes, when x is -3, what does u equal? The way you find that out is you bring it to the box. You put it in that first expression. So if x is -3, u is going to equal 2 minus 2 times -3, and that is going to give us 8. Okay? So now we know our bottom bound is 8. We're going to do the exact same thing with our top bound. We're going to bring that 1 in there, and we're going to do u equals 2 minus 2 times 1, and that's going to give us 0. So now I've got a new integral. It's written in terms of u. I can pretend I've never seen it before. Pretend it's a brand new problem, and you can just start. Okay? So when I'm doing this integral, I'm going to just integrate it the way it is. Again, for those of you guys who want to switch the top and the bottom bound and get rid of the negative, feel free to do it. Either way is fine. But I'm just going to integrate this and say, look, I'm going to get -1/2. That's just going to kind of come along for the ride. And now the integral of f double prime of u is f prime of u. So this is really going to equal f prime of my top bound minus f prime of my bottom bound. My top bound is 0. My bottom bound is 8. Okay? From here, I now have to go back and find f prime of 0 and f prime of 8. But that means going back to my graph. I'm looking for f prime of 0. I'm looking for f prime of 8. Remember, f prime of 0 is the slope at 0. So it's the slope of that orange line. The slope of that orange line, we've done it a bunch of times today. It's -1/2. Okay. And now I've got to find f prime of 8. And f prime of 8 is the slope of this green line. And that slope there, again, we've done it a couple times, but I believe it is 3/2. So I'm going to bring down these two values. Oops. I'm going to bring down these two values to here. I'm going to paste them. Okay. And now I'm going to fill them in. So let's just make sure I did this right. I've got a -1/2 f prime of 0 minus f prime of 8. I'm going to need my -1/2 again. Seems I forgot my negative. Let's put that back in. And now I've got my f prime of 0 minus my f prime of 8. F prime of 0 is -1/2, and f prime of 8 is 3/2. Okay, f prime of 8 is 3/2. So I'm going to show you a little trick here. There is my answer to the second part in green. Here's my answer to the first part in orange. I can literally take the time to write down all of these things and put them together and get my final answer. You can also do this. You can also write, let all of this equal A. And then you can write, let all of this equal B. And guess what you can write for your answer? You can write A plus B as your answer. Because you have defined the numerical value of A, you have defined the numerical value of B, you can give them a letter name and you can combine them. Okay? If you feel comfortable doing that, you can. A lot of us are just going to do what we've been doing all year long. We're just going to copy it over. We're literally going to write the exact same thing. And now we're going to bring down the other answer down to here. So that was -5/2, 1 squared minus -3 squared. So you can leave that answer as well, okay? So it's totally up to you, however you want to do it. Just remember you combine both answers at the end, because a lot of times a student will forget about that green answer they did so long ago, they don't remember to bring it back. So talk to me, all you calculus crammers out there, how are we feeling about this question, okay? Everybody feeling good about this? Because we're now going to move on. We're going to move on to a different STEM, a totally different type of problem, okay? And again, we're ignoring the time. There are no time limits tonight. We're just going to keep going. So if you guys are feeling good, I'm going to keep ignoring the fact that, you know, this is supposed to be an hour long, and we're just going to keep going. I see a question over here. How would you recommend using the graph this year? I'm not sure I understand the question completely, okay? You have access to graph paper. You're not going to have to draw anything this year. None of your answers are going to require you to make a graph. Where that's really important for us is you're not going to be asked a question about drawing a slope field or to draw a solution curve through a slope field with a separable differential equation. Okay, so you're not going to have to draw anything this year. So you're not going to need to have a graph that's exact. Now, you may want to have the graph. You've seen me draw on this graph over and over and over again today. Okay, you are allowed to print the question. So if you've got a printer and it's easy to do it, you can print the question. That is completely allowed. There is no problem with that. If you're in a situation where you don't have a printer, I admit this might be a more difficult problem to do because, you know, it's easier if we can draw on this, okay? For that reason, there are a couple of sample problems we've seen this week, and if you email me, I can send them to you, where the areas are actually labeled on the picture. So you're actually given the area of each shape. So they would write the area of that. They would tell you what that area is. They would tell you the area of this shape down here. It was written on the picture. They would give you the area of these two shapes, okay? So I've seen some questions like that, and if you're interested in seeing some samples of those, email me. I'm actually going to put my email. I didn't do it in the beginning, so let me do it right now. Here is my email address. You can email me for some more samples that they give where the area is written in. We may see them do that this year, specifically because what you're saying, it's much easier to find these areas if we can write on it. Okay. I hope I answered that question. If you have any follow-ups, please let me know. Okay. But if everyone's happy, I think we're good with this question. We're moving on to a brand new STEM. So I'm going to pop this up on the screen. I'd like you guys just to take a minute and read it and familiarize yourself with this question, and then we're going to talk about it. Okay. So the two questions there, Leah, are we going to be able to print the questions on the AP exam? Absolutely. If you have a printer and you have access to a printer, you may absolutely do that. The comment made by Mint, I am leaning towards what you're saying. You know, it's funny. You guys are actually making me think about the exam a little bit differently tonight because geometry is great, but it is a lot easier when you can write on it. So now I'm starting to think we might see a problem where they label the areas for you. Okay. So again, if you are interested, email me. And if someone can email me and remind me, I'll even attach it as a resource to this stream tonight, okay? So if someone can do that, I would be happy to do that. So email me for samples where their area is actually given, and that way you don't have to compute it. You can just use the areas that are on the page itself. So excellent point, Mint. I agree with you on that. We're looking at question 5 here, okay? So this is a table problem, and again, this is a problem that technology can't help you. So me and all of my colleagues, we're really, really force feeding all of our students these types of problems this year. So this is a situation where, you know, I've made up a little story here. During our AP exam on question 1, a student earns points at the rate P of T measured in points per minute, where T is between 0 and 25 minutes. We know P prime of T is continuous and positive on the interval from 0 to 25, okay? So what we want to do now is we want to approximate P prime of T. So this is a good question for the AB people and the BC people because they're limited on the number of questions they can ask this year that ask you to explain or interpret. The big unit in AB calculus that was explain and interpret was unit 8. It was taken off the test this year because of the school closings. So they really don't have a lot of questions they can ask about interpreting. That's why I really, really, really want you guys to be familiar with this question and comfortable. That's why we're doing it tonight. So without talking too much more about that, let's get to work. We are asked to approximate a derivative. Every single time we approximate a derivative, we're going to use something called the average rate of change. Okay? Average rate of change is the same as 2-point slope. 2-point slope is the same as delta y over delta x. It goes by many, many names, but that is the idea. So in this one, we're asked to approximate a slope at 6. We don't have direct information about 6, but we have direct information about 5, and we have direct information about 7, and 6 would fall in right in between there. Okay, so we are going to find f prime of 6 on this one, and I'm sorry, p prime of 6 by approximating. So this is what I would suggest you write. I see there's a question there, Akash. I'll get to that in just a minute. I'm going to answer this question first, and we'll talk mean value theorem. I'm asked to find this value and approximate it. I want an approximation symbol there, and now I just want to do a 2-point slope. I like to frame this for the person grading my exam. I like them to know that I'm finding P of 7 minus P of 5 over 7 minus 5. Okay, and then I like to do it. So now I find P of 7 is given as 4. P of 5 is given as 1. And then on the bottom, I've got 7 minus 5. At this point in time, you don't have to simplify, but you do need your units, okay? P has units of points per minute. So the top of this is going to be points over minutes. And then the bottom of this is going to be minutes. Now, for those of you guys who are familiar with acceleration, which should be all of you, you know sometimes we like to write acceleration as minutes squared on the bottom, and that's perfectly okay, okay? Oh, you guys caught a typo. You caught a typo. Thank you. These should all be minutes. Thank you for pointing that out, okay? They're not going to mix units on the AP exam. They are not going to do that. I apologize profusely. They should be consistent, okay? So they're not going to mix this. So that was just a typo on my part when I was typing this in. That should definitely be minutes, okay? So for that reason, we're getting points per minutes over minutes, okay? No conversions are necessary. Do not worry about that, okay? Just completely just my error. So thank you for catching it. You guys are good. If you want to write this as points over minutes squared, feel free. I avoid that because squared units don't mean anything to me personally. I understand this. This means I've got points per minute changing every minute. So I get this. So I'm going to leave it just like this. So you could leave this answer just like this. However, they want us to interpret it. And I find a lot of times that interpreting, it's nice to have a single number. Now, remember, you're all allowed to have a calculator out. You can do all your arithmetic calculation on the calculator if you want. You can do it by hand if you want. I'm going to go and just do this out and say this is going to be 3/2 points per minute, okay? And now we have to interpret the meaning. And the way we interpret the meaning, I'm going to introduce you to my 4-step process of interpreting the meaning of derivatives. All of you guys on AB, you're going to have to interpret derivatives. All of you guys on BC, you're going to have to do derivatives and integrals, okay? If you didn't watch my stream last night for you BC guys, I do a 15-minute discussion on how to do this exact interpretation. I'm going to do the condensed version because the AB kids don't need integrals. They only need derivatives. If you're on BC and you didn't watch it last night, take a look at the stream, the replay. We talk about how to interpret integrals as well. So again, AB, no interpreting integrals. BC, yes. Everybody has to interpret derivatives. So it comes down to using your number, your units, your bounds, and your direction. Now let me explain what I mean by that. In this problem, I'm just going to give myself a little more space. In this problem, our number is 3/2. Okay, that's our number. Our units are points per minute. That's our units. Our bound is our input. It's 6. It's the time bound. So that's 6, and that's 6 minutes. Okay, and then our direction is, are we adding to our result, or are we taking away? In this case, our derivative is positive, so we are going in our positive direction. That means we are increasing whatever's happening. Okay, we are increasing. So this is the key, knowing your number, your units, your bounds, and your direction. Okay, so now I'm going to switch back to my slides just for a second, because I want to share with you guys a template that we made yesterday. So let me find my slides. Here we go. So we finished up this question. Then we started this question, and now here is the template, okay? When you are asked to interpret the meaning of a derivative, all you have to do is fill in these blanks with the 4 things we just stated, okay? So at t equals, well, our bound was 6 minutes. I know you can't see my screen anymore, but we just wrote it down. So we're going to write at t equals 6 minutes. That's our bound in our unit. Now the subject of this particular expression was the rate of change of points being earned, okay? So the subject was the rate of points being earned. So again, at t equals 6 minutes, the rate of points being earned is increasing at a rate of 3/2 points per minute, okay? So this is the template. Every time you have to interpret the meaning of a derivative, this is what's going to get you through it. If you use this on all your problems, you're going to be fine. If you check out last night's stream, those of you in BC, we have the exact same thing set up for integrals, okay? So you can find the template for integrals. So I hope that makes sense to everybody. I'm going to say this answer again because I'm not going to do it when we go back. At t equals 6 minutes, the rate at which the student is earning points is increasing at a rate of 3/2 points per minute, okay? And that is how we're going to use this template. So I hope that works for everybody. Let me jump back over to my tablet. Okay, and that wraps up the first part, or question 5. That's the answer we need there. So hopefully everybody's good with that. If you have any questions, as always, throw them over there in the chat and we'll cover them. Let me enlarge this. And we're moving on. Oh, mean value theorem. Thank you for bringing that up. Okay, I almost forgot. So why is the mean value theorem not acceptable in this problem? Because if you had done the mean value theorem, you would have had this exact same expression, okay? And you would have said that this is equal to 3/2, and then that would be equal to P prime of C. Okay, P prime of C. So I'm going to finish my thought here, and then I'm going to come back and answer your question. I don't know where this 3/2 happens. I just know it's somewhere between 5 and 7. It might be at 6. It might be close to 6, and close is a relative term here. So this is why the mean value theorem doesn't answer the question directly. Now, going and reading your comment on the side, you're asking about mean value theorem from a differentiability standpoint, not stated only continuous. Be careful on this one. It says P prime is continuous. It doesn't say P is continuous. It says P prime is continuous. If P prime is continuous, that is another way of saying P is differentiable. So we do know that P has differentiability in this problem. Okay, so the mean value theorem is in play if we need it. It's just that we don't need it in question 5. Okay, so you seem to be good on that, Akash. I hope everybody's good with that. P prime continuous means P differentiable. Okay, so keep that in the back of your mind as we look at these problems. Number 6 is the Riemann sum. I'm going to make this a little bit bigger. You guys can see it better. The Riemann sum that we're talking about. So let's do this Riemann sum. Let's go from t equals 0 to t equals 25 of P of t dt. And now let's approximate that using a left Riemann sum with 4 subintervals, which means I need 4 rectangles. I firmly believe in just setting up your rectangles first, base times height, 4 times. I'm also a big believer in putting this all in brackets because this is one answer. It's all going to go together, okay? So now what I want to do is I want to find my bases. So looking at my bases, my first base goes from 0 to 5. That's a base of 5. My second base goes from 5 to 7. That's a base of 2. 7 to 15 is a base of 8. 15 to 25 is a base of 10. Okay, so I filled in all my bases. Now I go into height mode. And height mode is all about being the left Riemann sum. So when I'm choosing in interval number 1 between my 2 heights, I choose the one on the left. I choose 0. So my first height is 0. And that's okay. Not a big deal. That's the data. That's what we use. When I'm looking at my second interval, I'm choosing between 1 and 4. And I choose the one on the left. Okay? And the one on the left is 1. When I'm in my next interval, I'm choosing between 4 and 5. So I choose the one on the left. I'm choosing 4. And when I'm in my last interval, I'm choosing between 5 and 6. So I go with the one on the left. I am choosing 5. Okay. Now, this problem did not ask for an explanation. This problem did not ask for units. I just want to do it because I want you to be clear on how this works. If I think about units and I go back to labeling my two factors, P of t is measured in points per minute, and the differential is always measured in the variable that it's using, which is t. So the differential is being measured in minutes, which means this entire thing is being measured in points. So because I have my brackets, I can write points after this for a unit. And it is being carried on to every term, okay? That's why the brackets are important. If I leave those brackets off, if those brackets aren't there, now only this guy has the units, okay? And I want all of it to have the units. So I need those brackets, okay? So that's it. Now, this problem didn't ask for units. Chances are it's not going to penalize you for leaving units out, but I always like to be complete. For those of you guys on BC, very important, because this is where your interpretation is going to come from. And I know it's not a question on AB, but I'm just going to touch on it really quickly. What would be the interpretation of this? Well, if you were the kid taking this exam, you'd be interested. This is the number of points you earned during the first 25 minutes of that test. Okay, so that's what this represents, is the number of points earned by our student during the first 25 minutes of that test, from t equals 0 minutes to t equals 25 minutes. AB, you're not responsible for interpreting integrals, so you don't have to worry about that. But I hope it's clear why the units are playing a role here. Okay, that's all I want to make clear to everyone. So now we want to talk about under versus over approximation for this thing. Whenever you're dealing with a rectangular approximation, a left or a right Riemann sum, what's the key to figuring out if it's over or under? Let me hear from you guys. If it's a left or a right Riemann sum, what's going to tell us if we're an under approximation or an over approximation? Okay, so I've got the two answers that I want, and we have to discuss them. Increasing, decreasing, concavity. Both of these are important, but you have to use them in the right context. So in this problem, we are told that P prime is positive. P prime positive, this means P of t is increasing. Okay, that is important. So even though I don't know the exact graph, I know the graph does something like this. I know it's increasing. So as I go to make my rectangles on this thing, as I go to find my Riemann sum, and I draw my first rectangle, and I draw my second one, and I draw my third one, and I draw my fourth one, and keep going, okay? I am choosing a left-hand approximation. That means I'm drawing my heights from the left side. What do you guys notice when you look at this? How does the rectangle area compare with the actual area? Well, this is pretty clearly an under approximation. Here's the deal. If you have an increasing function and you are doing a left Riemann sum, that is always an under approximation. If you have an increasing function and you're doing a right Riemann sum, that is always an over approximation. Let me just draw that for you really quickly. If I was using the right hand, I would be going across this way. And I'd be going across this way. And I'd be going across this way. And isn't it clear that the right hand is giving me a bunch of area that is above the actual answer? So if you're talking about an increasing function, this is how you know over and under. Now, if you're talking about a decreasing function, we just got to reverse everything. If we've got a decreasing function, all right, and again, I'm going to move this down so I can draw it again. If my function is decreasing, and I am doing a left Riemann sum, well, now look what happens if I'm a decreasing function. I got that over approximation happening. And if I'm a decreasing function and I'm a right Riemann sum, well, in this case, I'll be drawing it from the right side. So as you can see, I am under the actual answer. Okay, so that would be an under approximation. You might be wondering, concavity came up. Well, concavity is not unimportant. Concavity is important. It's just not important with rectangles. Concavity is not important for rectangles. Concavity is important when we're talking about the trapezoidal rule. Okay. trapezoidal rule. So when I draw a trapezoidal approximation, let's look at this guy. If I do a trapezoidal approximation on this guy, and I do the Riemann sum, oh, I got to draw this a little better, I'm sorry. Let me make it a little clearer. If I am drawing a trapezoidal approximation, and I've got a function that looks like this, okay, I'm doing my trapezoids, and I make my trapezoids. What can we tell about this? This is an over approximation. But what makes it an over approximation? It can't be increasing and decreasing because this function is actually doing both. What makes this an over approximation is that we've got a concave up function. So if you have a concave up function with a trapezoidal rule, that is an over approximation. If you have a concave down function with a trapezoidal rule, that is an under approximation. So that's where concavity comes into play. Okay, so these are the two ways you're going to find out whether or not your Riemann sums are over or under approximations. So I hope that's clear, everyone. I see a couple of questions. Let me take a look. Looking at the table going from left to right, we see that P of t is decreasing. I don't see that. I see P of t is increasing. P of t starts at 0, then it goes to 1, then it goes to 4, then it goes to 5, then it goes to 6. Okay, so I think P of t is increasing. So I think we're okay there, Akash. I think you just made a careless error there, okay? So are we good? Okay, great. Is everybody good with over versus under approximations? Okay, give me some feedback because I'll move on. The last thing I want to say, just about over and under approximations. If it's a tangent line approximation, not related to this question at all, but it could come up. If you're a tangent line approximation, this is going to be an over approximation on that tangent line because the tangent line is above the shape. But if I change my shape and I draw it like this, and now I draw a tangent line, now I have an under approximation. Do you guys see that over and under approximations on tangent lines are about concavity? It's the concave up, concave down. So if you're a tangent line on a concave down shape, you are over. If you're a tangent line on a concave up shape, you are under. Okay? So that's the other place approximations come in. So I just want to throw that in to kind of be complete. So I hope everybody's okay with that. We're moving on to what is the last question for this particular problem. And we've already kind of talked about it, to be honest with you, but we're going to do it together. Is there a time C such that P prime of C equals 2/5? The College Board loves giving you hidden clues, and this one's not even that hidden, okay? But the clue is they're asking you for a derivative, and they're using C. They do that when they're testing you on the mean value theorem, okay? They do it all the time, and it is almost always the mean value theorem, because the mean value theorem in general says f of b minus f of a over b minus a is equal to f prime of c if f is differentiable and c is between a and b, okay? And it literally uses the letter C in every textbook known to man to talk about the mean value theorem. So the College Board thinks they're funny by throwing C in it and seeing who doesn't recognize it. So this, to me, is saying mean value theorem. But remember, it's not mean value theorem unless our function is differentiable. You guys already pointed out earlier, this function is differentiable because P prime is continuous. So we know it's differentiable. So the way I'm going to answer this question, I'm going to state my facts first. I'm going to say, because P prime of t is continuous, that means P is differentiable. So mean value theorem applies. You may use the abbreviations for the theorems, MVT, IVT, EVT. You can use the abbreviations, okay? So now that I've proven the conditions, now I'm just going to do it. So I'm going to do P of B minus P of A over B minus A. But here's the deal. I'm not using the entire interval. I'm using whatever interval gives me 2/5. Okay, I've got to find an interval that uses 2/5. So I've got to go up to this table, and I've got to scan all the values, and I'm looking for a 2-point slope that's going to equal 2/5. So where am I going to find it? Well, I want to be honest. The first place you should look are the endpoints. They like to do it on the endpoints, but the endpoints are going to give me 6/25. That's not going to cut it. So it's not going to be the endpoints. So now I just got to kind of scan the table and see where I'm going to get 2/5. If you look hard enough, you're going to find it. It's going to be between t equals 5 and t equals 15. T equals 5 and t equals 15. Yeah, it's going to be right there. So that means I'm going to do p of 15 minus p of 5 over 15 minus 5. I'm going to do the values that go with it. So I'm going to do 5 minus 1 over 15 minus 5 is 10. That's going to turn to 4 over 10. That's going to be 2/5. That's going to be equal to p prime of c by the mean value theorem. If I write this statement at the top, or actually anywhere on the paper, it doesn't matter if it's on the top or not, as long as you have that statement right there, and you have this difference quotient, you're walking away with full credit. Okay, that's it. That's what they're looking for. Okay, you need those two things to get full credit on this. That is the final question I've got planned for you guys tonight. But I am open now. I got a couple minutes. Any questions at all you want to pop over on that, about topics on the calculus exam, about the testing itself, about what Fiveable is going to be doing over the next couple of days? We can do that. So can I go over what the definition of differentiability is? Yes, I can. Okay. Okay. Differentiability. Here we go. And if you need a further discussion, email me, because I did a video for my own class, which I'll share with you guys, about differentiable. So if this is not good enough for you guys, email me and say, hey, can you share your differentiable video with me? And I'll give you my YouTube channel, and you can check out my differentiability function, okay? So differentiable, just in a nutshell, real quick. First thing, f of x is differentiable if, and there are two conditions, okay? First condition, f of x is continuous. You cannot have continuity. You can't have differentiability without continuity. So you got to have continuous first. And then if the limit of f prime of x as x approaches the value from the left is equal to the limit of f prime of x as x approaches the value from the right. Okay? So that is it. That is it. You've got to show this. It's very, very similar to the continuity definition, except for you're doing it with the derivative. And there's only two parts. You don't need the f prime of a. So this is it. So this is your definition of differentiable. The place differentiability happens on the exam all the time is in these graphs. I'm going to back up to the top. In these graphs at the corners. We talked about it tonight. We talked about it right here, how the derivative from the left doesn't equal the derivative from the right. This is what we're talking about, okay? So you're going to, if it's going to get used on the exam, it's going to be at the corner. So you want to know that definition of differentiability. So quick, that's it. That's the definition of differentiability. The places you see it are on graphs where they have corners. The other place you see it all the time is when they give you something like this, and it's a piecewise function. So you've got one function up here, and you've got another function down here, and you've got x has some interval on this side, and then x is some interval on that side, okay? You have to prove it's continuous first, and then you have to show it's differentiable by using this right here. So that's it in a nutshell. If you have a follow-up question, let me know. If you want my video, I will share it with you. You're asking my YouTube channel. I don't know it off the top of my head, but I can try to find it here in a minute if you give me a second. You can certainly email it to me, and I can give you the direct link. I mean, that's not a big deal at all. So that's it for differentiable. If you have a follow-up question, let me know. EVT and IVT. Okay. EVT. Extreme value theorem. F of x must be continuous. You must have an interval that x is on some interval from a to b, and it's got to be closed. Okay, a to b. Here's what the extreme value theorem says. It says, if you start here at A f of A, and you end here at B f of B, somewhere between A and B, you have an absolute maximum and an absolute minimum. That's the extreme part of it, okay? You have an absolute maximum and an absolute minimum. In other words, it is impossible to draw a graph that doesn't have a maximum and a minimum. Now, I'm going to show you a couple of examples real quick. If I do this, it is pretty clear that my minimum is here and my maximum is there, okay? Extreme value theorem guarantees it. There's going to be some place where you have an absolute maximum and an absolute minimum. What if your graph looks a little different? What if your graph looks like this? Oh, I'm sorry. Just a straight line, okay? Again, no big deal. Your absolute minimum is f of A. Your absolute maximum is f of B. You're going to have a highest and a lowest point. What if your graph looks like this one? This is the one that always screws my students up when they first see it. What if f of A is here and then f of B is the exact same thing? Well, then maybe your graph looks like this. Does this have an absolute maximum? Well, believe it or not, the answer is yes. The absolute maximum is the y value f of A, but it is also the absolute minimum because this function only takes on one value. So every value is the maximum, every value is the minimum. A lot of students don't like that, but think of it this way. Let's say that you are the all-time greatest AP exam taker. You've taken every AP exam known to man. You've gotten a 5 on every single AP exam. If someone asks you, what's the highest score you ever got on a 5? You're going to say, on an AP exam, you're going to say 5. What's the lowest score you ever got on the exam? You're going to say 5. 5 is your highest and your lowest score because every value you get is 5. So the extreme value theorem is just it's a common sense thing. You're going to have a maximum value and a minimum value for every function you draw. Now, you might be wondering, well, why do I need continuity? Because if I have continuity, I can't do this. Because if I do this, I do not have an absolute maximum. This y value goes all the way to infinity. And this y value goes all the way to negative infinity. So we don't have an absolute maximum and an absolute minimum. The extreme value theorem, you need continuity. So that's the idea of the extreme value theorem. Of the two, extreme value theorem is not tested anywhere near as much as intermediate value theorem. So that's why I'm saving that one for the end, okay? So there's extreme value theorem. Intermediate value theorem, okay? Intermediate value theorem starts off the same way. F of x has to be continuous. And it must be on an interval from A to B. This is what the extreme value theorem says. It says if you've got an interval from A to B, and this is f of A, and this is f of B, it says you hit, it says your function, why is this doing this? It says your function touches every y value in between these two y values. Okay? It says your function touches every y value in between those two y values. In other words, let's say this guy down here is 5. And let's say this guy up here is 12. And they say prove f of x equals 10 somewhere. Okay? Prove f of x equals 10 somewhere. We can do it. We can prove f of x will equal 10 somewhere because we can say f of x is continuous and f of a equals 5 and f of b equals 12. So somewhere between a and b, we're going to hit a y value of 10 because the y value 10 is here. Well, there's no way to go from a to b unless I cross 10 because I am continuous. It's all about being continuous. So somewhere in between, I've got to hit that y value of 10. There's no way around it. We see this on table problems a lot, okay? They give you a table problem, you see two values, and they say, how do we know we go through a value that's somewhere in between? You say the function's continuous, you say the intermediate value theorem, and that gets you what you need, okay? So in a nutshell, there's EVT and IVT and differentiability. Do you guys have anything else you want to discuss this evening? If you do, put it over on the chat. If you're happy, give me some good feedback and say you've enjoyed it and we're doing great, and we'll get together again on Monday. But I've got a few minutes. If you got anything else, let me know. Does it have to go only through? We can only guarantee it goes through once. It could go through multiple times. You could have a function that behaves kind of crazy, and you could see a function that does this. And that's fine. But we can't guarantee it. We can only guarantee it goes through once. Okay, so that's the deal with IVT. Again, any other questions? Pop them up right now. Otherwise, give me some feedback on how tonight went, and I hope things are going great. You know, we're on the home stretch. Tuesday's the day. Monday, 7 to 9. Come back and see me some more. Bring your questions then. But I got a couple of minutes. Anything else you want, tell me now. Remember to email me, okay? Email me to ask me those questions. Email me. I'll get you the YouTube channel. I just started it this month. There's not a ton of videos on there. There's probably about 7, so you're welcome to use them. If you email me directly, I will definitely share that with you. The email is jamil@fiveable.me. It's up in the comments earlier. Other than that, hey, I hope you guys. Oh, I see another question was asked. Let me check this out. Squeeze theorem. Okay, so here's the deal on the squeeze theorem. Okay, first thing I want to say about the squeeze theorem, they're not going to ask it, in my opinion. 50 years of college board exams, it's been asked once, and it was last year. But the squeeze theorem basically says, if you've got f of x and you've got g of x, and you've got h of x, and you have this relationship that f of x is less than or equal to h of x, and h of x is less than or equal to g of x, and everybody has to be continuous. Everybody's got to be continuous on this, okay? So if you know this, and you take a limit, and you find out that the limit as x goes to some value ends up being a number, we'll call it L, and you take the limit of this one as x goes to the same number, and it ends up giving you the same output, then you know for a fact that h has to get squeezed in between and end up at the same answer. So in other words, if you took the limit as x approached 7 of f of x, and you got 20, and then you took the limit as x approaches 7 of g of x, and you got 20, you know automatically that the limit as x approaches 7 of h of x has to equal 20. Okay, you know that. You don't have to know anything else about h. It is squeezed between g and f, so it has to stay between it. But because g and f both go to 20, you literally see h getting squeezed into 20 as well. Okay, that's the squeeze theorem. I can't imagine they're going to ask it back-to-back years. If you're interested in seeing a question on the squeeze theorem, look at last year's question 6 on the AB exam, I believe. It was the squeeze theorem, okay? It's not so much you have to prove it, you just have to state the conditions. You have to say that you gave us this was true, because they'll give you that, and you gave us they were all continuous. So as long as you state those conditions, you can now say, if the two outside functions go to a certain number, the one stuck in the middle has to go to that number. So that's the way you would use it. Okay, you really wouldn't have to prove it other than that, other than just stating the conditions of the test. Other questions from you guys? We've been going strong for about 93 minutes now, but this has been great. I hope you found this to be useful. I am really focusing on what me and some of my colleagues feel like are the most important questions that you guys are going to see on Tuesday. We're doing our best. We're making our best guess. Don't hold it against me if we're off by a little bit, but I'm feeling pretty confident that the stuff that we're talking about is really, really going to be essential to what you guys need on Tuesday. So I'll stick around another couple minutes. If you've got any questions, please ask. If you don't, a little bit of feedback on the side goes a long way for me preparing for our next session, which will be our last session. Monday, I'll be on 7 to 9. Fiveable will be going strong from 4 to 9 Eastern time. So any other questions, please put them over there in the chat. Other than that, you guys have a great night. I'll stick around another 30 seconds to see it. 4 to 9 is a lot of time. That's why I'm only doing 2 hours, and some other people are filling in the beginning, okay? So I'll be there 7 to 9. Thank you for that comment. I really appreciate it. Are these questions on the resources? All the questions that I've posted here are in the slides, so you'll see them in the slides. So all the questions we did tonight are on the slides, which are posted on the resources. If you guys need any other resources, again, email me. I will respond within 24 hours. I'll get back to you. Glad you found it useful. All right, you calculus crammers, I'm taking it like we're done for the evening. I don't see any other questions coming up. Thank you very much for tuning in. I've appreciated your working with me the last couple of weeks. I just hope that I've been able to help you guys a little bit, if not a lot, help you prepare for this exam and get ready, because we got one more night on Tuesday night. Looking forward to talking to you guys all then. Have a great weekend. Feel free to email me with anything you need. And just remember to find some time, just relax, stay calm, don't stress. You guys are going to do fine. All right. So have a great night, everybody. Thanks for all the comments. We'll see you on Monday.